Hello guys, welcome to my channel Maths Pursuit. Today we are going to look another theorem and last theorem of this chapter called theorem number 1.7. This theorem will show us in what conditions a rational number will will not terminate. That means we will have recurring digits. So let's see what exactly is given in theorem number 1.7. So coming to the theorem, it is mentioned that let x is equal to p by q be a rational number, like x is a rational number, such that the prime factorization of q is not of the form 2 to the power n and 5 to the power m, where n and m are non-negative integers. Guys, earlier in the other two theorems, we saw that the prime factorization of q should be of the form 2 to the power n and 5 to the power m, but here we are seeing that the prime factorization of q is not of the form 2 to the power n 5 to the power m. So then x has a decimal expansion which is non-terminating, repeating or recurring. That means if this is the condition that the prime factorization is not of the form 2 to the power n and 5 to the power m, then the decimal expansion of x will non-terminate or repeat or recur. Okay, so let's analyze this. What are the things given in theorem? So the first point is like prime factorization of q is not of the form 2 to the power n and 5 to the power m. Second point is like n and m non-negative integers. So these two conditions, if any rational number of the form p by q, and if it satisfies these two conditions, then definitely we will see that the resultant decimal number is non-terminating, repeating. That means it is recurring. So let's take an example. Coming to the example, like we need to consider x is equal to p by q, and let us assume p is equal to 13 and q is equal to 3 to the power square and 5 to the power square. So we have considered the factorization of q in such a way that they are like p to the power square at like 3 to the power square and 5 to the power square. Now putting these things in our safe, like x is equal to p by q, so we are getting x is equal to 13 by 3 to the power square 5 to the power square, which is nothing but x is equal to 13 by 3 square into 5 square, and after further solving I am getting 13 by 225. Or I can write x is equal to 0.05777. We could see that like once 13 is divided by 225, we could see that we are getting a repeating decimal digits, which is like 0.5777. So this 777 keeps on repeating. And guys, if you notice that here the factorization of q are in the form 3 and 5, it is not of the form 2 and 5. So if we would have 2 to the power square and 5 to the square, then definitely it would terminate. But here you could see instead of 2 you are seeing 3 with 5. So if any number comes apart from 2 and 5, then definitely our decimal will not terminate. It will be a non-terminating or repeating or recurring. So thus we could see that x has decimal expansion which terminates. Hope guys you understood this calculation. If you still have any questions or concerns, kindly reply back to me in the comment section. Definitely I will get back to you once I see your comments. If you really like my videos, kindly subscribe and let your friends know. This will motivate me to make similar type of videos in the future. Thank you. Bye.